In this new video, in which we will implement a big data architecture based on Kubernetes Dataops. First of all, in a production environment, you may need to deal with huge amounts of containers, and you need to manage the containers running the application to ensure there is no downtime. So managing thousands of running containers on a cluster of machines by hand sounds like an unpleasant task. It's a problem of how to manage the life cycle of container applications and services, defines how applications should run, how they are intended to interact with other applications on the outside world while providing predictability, scalability, and high availability. And this is what Kubernetes can do for us. It's all the rage these days and highly so on. The open source project, originally created by Google, is designed to automate the deployment and management of your container application. It's really one of the most interesting aspects of Kubernetes, especially with the platform designed to help development and operation teams so faster. Let's first of all discover our pipeline. We will show how to integrate Apache NiFi with Kafka by producing and consuming to and from a topic. This data stream receives tweets from Twitter in real time using a process getTweeter, then loads into a Kafka topic through the publishKafka. In a second step, we will consume this input data in real time with Apache Kafka through consumeKafka, and keep them in MongoDB with putmongo. For sure, all this architecture will be implemented based on Kubernetes. So, let's first of all understand the Kubernetes deployment model. It's possible to keep development in Kubernetes with local cluster or with remote cluster, which is cloud. For our example, we will implement or install and manipulate a Kubernetes cluster with MiniCube, means locally. So, MiniCube is a tool that makes it easy to run Kubernetes locally. It runs a single node Kubernetes cluster in a virtual machine, so your VM becomes both a master and a worker node. To install Kubernetes, what you need is 2 CPU for or more, 2 GB for free memory, 20 GB for free disk space, and of sure an internet connection. So let's discover our work on the VM. So here is the MiniCube start. After your installation of the hypervisor and MiniCube are complete, you can start your local cluster. So here you need to replace with the MiniCube start your driver with the hypervisor you are using. If you want to use your physical machine as a node, then use the VM driver option, the MiniCube start command with the value none. And this is what I did in this example. So this option will run Kubernetes components on your host machine and not on virtual machine provided. You have the Docker engine on your Linux host machine, which gives us the following command, which is MiniCube start and given the option of driver equal none. And here is the MiniCube dashboard. Launch the MiniCube dashboard with sudo MiniCube dashboard, which is a web-based user interface that you can use to manage clusters and deploy applications. It can provide also an overview of your cluster operation and make it easier to modify any resource you have running. You can also use it to monitor the state of your cluster resources. So here I created a folder named application in which I create subfolders for NiFi ls to list the folders. So here we have some examples of what I did. Let's get an example for NiFi. And I will open the YAML file configuration for NiFi. For the service, in this file you must specify the NiFi HTTP and the HTTPS ports as well as the target port. You must also specify an app here, NiFi. It's like a key which must be the same in the different YAML file to interconnect them. Not port here is or expose the services on each node's IP at a static port. You will be able to connect the node port service from outside the cluster by requesting node IP or the type of node port. For the deployment YAML file or part, we just configure the Apache NiFi instance to use single user mode here with one replication. Here in the specification part, we will mention or launch our containers image, pull this image if not present, and get the month path and the container port or a target port also. For the volume part, local persistent volume claim. It's a PVC, which is a request for storage, which is made by bending the PVC to persistent volume. It provides an abstraction layer to the underlying storage. So here we use the persistent volume claim to get the availability of the data. This is the part of the configuration to deploy NiFi components on Kubernetes or on MiniCube. So now, to apply this file, use kubectl, apply with the option of F to say force. We use kubectl apply, which will create and apply the file in the same time. Here it's already created. Offshore here we should also launch the name of the YAML file. And like this our deployment is affected. So here, before moving to Kafka and Zookeeper, it's very important to be able to compare things, especially when use stateful set application and the stateful-less application. A stateful-less application is one that does not care which network is using, and it does not need permanent storage. NiFi, for example, it's a stateless application. For this reason, we get the kind deployment and not here, and not stateful set, because stateful set applications in which you have a database cluster that is managed by a serverless Zookeeper instance. For example, Kafka should be deployment as a stateful set kind. Now, in order to open YAML file in for each component, I will directly go to the dashboard, in which it's also possible to get configuration file YAMLs. So here is our dashboard, beginning with workloads, in which there is a part for state pods Green, that means all pods are running correctly. So here we have general information such as deployment, pods, also replica set, stateful set. So here for the deployment part, you can get it also from here. We have NiFi. We can get information about NiFi, and even we can get our YAML file about NiFi here, the deployment part. If you want to see the services part, we get here for NiFi service. The port for HTTP and HTTPS, also the target port. So here all the pods are running correctly. The state is running. We have NiFi, Mongo client for the part of storage data, Kafka and Zookeeper. Here we can get stateful set, which is Kafka. There are a variety of reasons why Kafka is architecture in Kubernetes is attractive. If your organization is standardizing the use of Kubernetes as an application platform, then this is a great reason to consider running Kafka there as well. Running Kafka on Kubernetes or Minikube enables organization to simplify operations such as updates, restarts, and monitoring that are more or less integrated into the Kubernetes platform. Without doubt, Kafka depends on the keeper to track its configuration of what topics are added or removed to server subscribes. So first we have to deploy Zookeeper in the cluster. Here we have deployment, Zookeeper. The YAML file or the configuration file of Zookeeper is here. Kind is deployment, means that is a statefulness application. We get one replication because the most important is to implement the big data architecture. We can also test the high availability offered by Kubernetes. Here we have our container image and the pull policy if not present. So this will create a deployment of Zookeeper with one replica. Apache Zookeeper is a strongly consistent distributed system used by other distributed systems such as Kafka for cluster coordination and configuration management. So here we have Zookeeper running correctly. We can have all the information about this pod, even from pods. So here we have Zookeeper. Click on Zookeeper. From here you can get your container image and the environment variables. So since Zookeeper is correctly deployed, it's time to speak about Kafka. So Kafka configuration file or YAML file, especially for deployment part, which is stateful set application. For this we mentioned kind as stateful set. Here the stateful set is the workload API object used to manage stateful application and manages the deployment and scaling of a set of pods and provides offshore guarantees about the ordering and inquiries of these pods. The same manner with our image policy pooling and the container port and target port also. Here we have the Zookeeper connection. It's very interesting it's very important to put the interconnection with the Zookeeper. We likely know Kafka as a durable, scalable, and fault-tolerant publish-subscribe messaging system. It's also supported very interesting monitoring part with Kafka Manager. So here I implement also Kafka Manager to facilitate the control and the creating of topic without need to the terminal part. It's also using user interface. Here we have the conditions of our Kafka manager. All the states are true, so it's correctly running. And here for the deployment part, we have also our pod deployed, which is Kafka manager. Here we have the YAML file deployment. And also the most important part is the connection with Zookeeper service and pulling the image container. So Kafka Manager is an open source tool introduced by Yahoo to manage and monitor the Apache Kafka cluster via user interface. It's time so to run Kafka and Zookeeper with the CMD part, kubectl, apply, and the file name. At this point, the Kafka cluster is running. I can check the pod and services in the Kubernetes dashboard as well as through kubectl in command line. I can tap, for example, sudo kubectl get all, meaning get all the information about all pods. Here we get my password. And there all the pods and the services and the deployment part within also the replica set and stateful set application. So all the state is running, are ready also, are up to date, available, and ready. I prefer to monitor and to control all the pods directory in the dashboard. It's very easily, and this is one of the most important features of Kubernetes. So here is our URL. We will be directly going to the Kafka manager user interface of sure. So here we have our cluster of Kafka cluster. It's not this is not of sure a creation of new Kafka cluster, but instead the registration with Kafka manager of an existing cluster. So here we can create a new topic list we don't have. So we are going to add the cluster. For example, Zookeeper Kafka, and put the Zookeeper service and its port. I save information and we are adding a cluster Kafka. So here we can launch our new topic. I will make the name of the topic is tweets. Okay, I'm not writing tweets. Data produced by Kafka will be consumed on this topic named tweets. And here create. That's also another features or benefits of Kubernetes, that is facilitates monitoring, creating topics, creating operations without need to be in the CMD part. So here Kafka and Zookeeper are already present to be using. So let's get a discover about MongoDB, our NoSQL database, in where we will store our data or our tweets. Here we have, it's very interesting to know that in the case of our MongoDB deployment example, here we have the deployment Mongo client. Let's get the configuration file. We will use the normal server with notepar here. So this is the Mongo deployment YAML file, in which I added an explanation for Mongo deployment, such as the app, which is the key to interconnect all the YAML file. Here we have our container image and value. And for the part of services, here we have Mongo service and the YAML configuration. I had created a notepar type services and saved the below Kubernetes Mongo services YAML as Mongo notepar CSV for services. So here I put the target port also and the type node port. For load balancer, normal Kubernetes services acts as load balancers. Persistent volume, such as for Mongo data. Here we have the configuration file to set data Mongo or Mongo data persistent volume. So after the pod was created, it's time to test if Mongo is well running and well created as a pod. Here I prepared these commands to access to the Mongo client. Services URL Mongo and the name of the services will give us the IP address and the port of MongoDB for Kubernetes based on MiniCube IP offshore, and I execute with kubectl the deployment Mongo client and open the bash line. Here I was redirected to the Mongo client and I put Mongo to in testing the running pod with show databases, and I create a database named tweets in which our tweets will be stored. Like that, our three component big data or our pipeline or our big data architecture is ready to be implemented. So like that, our pods are available, are prepared to be in used. So we have to launch the NiFi user interface and producing tweets from with the processor getTweets and put them in the topic of Kafka and offshore publish them into Mongo to store them.